Today we're going to look at problems involving more than one right triangle. So if I look at this diagram, I can see three triangles. I can see two right triangles and one large non-right triangle. So that yellow triangle is not a right triangle. So whenever you have a triangle that's not a right triangle, you're not allowed to solve for missing sides and angles using sine, cos, or tan, or using SOHCAHTOA. So we're only allowed to apply these sine, cos, and tan laws to right triangles. We will learn other rules later in grade 11 to find missing sides and angles using other methods, but this year we're just working on right triangles. So all we can do, if we want to find this side x, all we can do is use a right triangle. So I look at this right triangle right here, and I try to solve for x, and I don't have enough information. All I have is an angle. I don't have any sides. So I need to perhaps use this right triangle to help me lead to enough information to get to x. And I can see between those two triangles, they have a shared side. They share a side in common. So if I can find that shared side in the blue triangle, I can use it in my yellow triangle, and that's the strategy. So if this is the side I want to find, and this is the angle in my blue triangle, I'm going to use opposite and adjacent, which is our tangent ratio. So the tan of 63 equals the opposite, my shared side, divided by 2.4. And then I can calculate my shared side by calculating 2.4 multiplied by tan 63. And again, within a problem, you don't want to round off too much if it's not a final answer. Let's say I want my final answer rounded off to the nearest decimal. I would probably not, or round it off to the nearest unit. I'd probably not round off to the nearest unit here. I'd give more units. The more units you give within, the more accurate you are when you round off at the final answer. So now that I have my shared side, as many decimals as you'd like, the more you give, the more accurate you are. I can now use that shared side to find x, in which that is opposite, that is adjacent. So the tan of 29 is equal to opposite over adjacent. And so now I can find x by taking my 4.71 and multiplying it by tan 29, and I'm going to get rounded to the nearest tenth. Since the final answer, that's all right, I'm going to get 2.6 units. Here's another example. I want to find length AC. I want to find this length right there from A to C. And you'll notice that length AC is part of a triangle, but the triangle that it's part of, again, is not a right triangle. So finding any pieces of that triangle does not help me find AC. Right? Because it's not a right triangle and I can't use sine, cos, or tan. So I have to find lengths and sides of right triangles to help me find AC. So my suggestion would be, well, look for right triangles. I can see one right triangle, which would be this triangle right here. Right? Using this triangle in the 33-degree angle, I could go ahead and find, let's call it W, right? DA. So by finding W, I can find that length. Or I could use this right triangle, the whole large one, right? So in other words, if I ignore this line here and pretend it's not there, I have that big green triangle in which this angle is 63 degrees. Oops. And I can find that whole DC side, which maybe I'll call Y. Okay? So I can find X simply by finding Y, finding W, and subtracting the two, because Y is the whole length, W is part of it, X is the other part, so when I subtract them, I would find that answer. I'm not going to go through all of the work doing that. I think we all understand how to find sides and angles now. I'm just giving you the strategy. All right? So a reminder when we're naming an angle, let me go back to the original question up here and practice naming angles. If I asked in this original question for angle ZXY, angle ZXY, This is one angle. It's not three different angles. It's not angle Z, angle X, angle Y. Angle ZXY is the angle X. The middle angle is the angle. The Z and the Y are the endpoints that help create it. For example, angle X, it could be, are we talking about that angle? Are we talking about that angle? Or are we talking about that angle? So angle Z means start at Z, go to X, and finish at Y. Oh, we're talking about the entire angle. Angle ZXY, again, is not part of a right triangle, so we can't use SOHCAHTOA to find it, but we do have the ability to find smaller angles of right triangles. So let's practice that down here. Find the measure of angle XYZ. So X to Y to Z is that entire angle. I want to find that entire angle. It's not a right triangle, but I could find that blue angle, right, using the blue triangle, opposite of 3, adjacent, tan of angle Y, right, or let's call that A. Tan of angle A is equal to opposite over adjacent, and whenever we're finding an angle, we're going to do our tan inverse of our opposite over adjacent. So shift tan, 3 divided by 4, I'm going to get approximately 37 degrees, or I could round off more accurately and give more decimal places. And then I'm also now going to find that angle right there. Perhaps we can call that B, right, of our other right triangle on this side, correct? So now I'm going to say, well, the tan of B is equal to opposite to that angle as compared to adjacent. And to find an angle, again, we do our tan inverse of the ratio. It doesn't equal the ratio, it's of the ratio. So tan inverse of 5 divided by 4 gives me 51 approximately, if I'm rounding off there. And so now A plus B gives me my entire angle, which is going to be our 88-degree angle for angle XYZ. Okay? So I can even put that there. Angle XYZ equals A plus B, which equals. And just like before, sometimes we have to subtract to get our angle. So for example, angle XYZ is going to be, I erased my Z, there's a Z there, all right. Angle XYZ is going to be right here. Right in there, there's angle XYZ, okay? And that angle right there is not part of a right triangle. Triangle XYZ is not a right triangle. So finding sides, if I found XY, the hypotenuse, I could find it, but it doesn't help me because I don't know. I can't apply SOHCAHTOA, okay? So what I have to do is I have to find angles of right triangles to help me get there. Well, again, I can see this triangle. 5, 10, right? And I could find that angle down there. So I could first find this angle, which I'm going to call A, using our tan. Tan of angle A equals 5 over 10, and then we can find angle A using tan inverse. Next, again, I could pretend that line's not there, right? And I could see the whole large triangle, and I could find this entire angle, and maybe I'll call that entire angle B, where this is 8 and this is 10. So I would go the tan of angle B is equal to 8 over 10, and then I could find angle B, correct? Well, this angle right in there, the one I want, is going to be the angle B, subtract angle A, is going to get us to angle XYZ. All right? So again, I'm not going to go through all the answers. I'm just giving you your strategy of how you're going to find that final answer. All right, and last but not least, you should be able to draw diagrams that involve scenarios. Now, when you're drawing your diagrams, please, 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 don't just draw a right triangle and try to stuff numbers in. Draw the scenario, then read through and put in numbers, then read through and put in your X of what you're trying to find, and then you look for your right triangles. So I have a lighthouse located on the top of a cliff. So I'm going to start with my cliff, right? And I'm going to have a lighthouse on top of the cliff. And there's water here, right? Because there's a shoreline, there's water. And we have a boat out in the water. Okay. So from a point 150 meters offshore, right? Offshore means, okay, there's the boat, it's offshore. That's where the water meets land, that's where the shoreline is. So offshore is 150 meters. The foot of the lighthouse, so that's the bottom of the lighthouse, the foot of the lighthouse has an angle of elevation of 25 degrees. Angle of elevation goes up, so that's 25 degrees. And then to the top of the lighthouse has an angle of elevation of 31 degrees. Where do I put that 31 degrees? It doesn't fit in there, it goes from there. That's 31 degrees. Okay? And you can see that this diagram is just like the one we did earlier, right? Where we have two right triangles. We have our small right triangle right there, in which we could find the height of the cliff. Okay? We have our larger right triangle, that whole entire one, right? That one in there is not a right triangle. The large right triangle, which we'll call Y, finds us the height of the cliff and the lighthouse. So the height of the lighthouse is just going to be the entire length minus the length of the height of the cliff. All right, so just drawing your diagram properly helps us. I know that angle in there is 6 degrees, but it doesn't help me because the 6 degrees is not part of a right triangle. I can't use SOHCAHTOA. Okay.